Students, now we're going to do from this exercise 1C from SLAB 2 question number 11. So from this exercise 1C from SLAB 2 question number 11, and here's the question is find the greatest number. If you recall, if you look back and see the other videos and see a book, you'll find that in question number 9 and 10 we were asked to find the smallest number. Okay, in question number 9 and 10. Okay, 9 and 10, find the smallest number. We have done this too in videos 21, 22, 23. Okay, now in this question number 11 they have asked us to find the greatest number of 6 digits. That means what? The answer that they have asked you to find, the number that is required to be found, that number should have 6 digits. Okay, I think you all know that numbers are made up of digits. Okay, to find the greatest number, that number should be the greatest. There should be no other number more than that. Find the greatest number of 6 digits, and your answer should have total 6 digits. When you write, there should be 6 numbers. Okay, 6 digits, and that number should be exactly divisible by 24 also, 15 also, and 36 also. That means what? Two things to be kept in mind. Number one, the greatest number should have 6 digits, and second thing, that greatest number should be exactly divisible by 24, 15, 36. That means what? When you divide that answer, that greatest number, by 24, 15, 36, remainders should come 0 in all the cases. Okay, so let's see how we can do this sum. Okay, how we can do, or how should we do. So before we do this sum, let us first understand about the digits. Okay, about the 6 digits, 5 digits, greatest, smallest, whatever. So this will help you. Okay, so first of all, see the student, small note I've prepared for you. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all your single digits. Why single? Because when you write them, you write only one number. Suppose I write 0, I write only 0. I write 4, I write only 4. And after write 9, I write only this 9. Okay, and these are there in your mobile keypad also. Like when you dial numbers, these are there to dial the numbers. Okay, no matter what is your telephone number, 10 digits, but then you press all this. So these are all single digits. If you look very carefully, the smallest single digit is 0, and the largest single digit is 9. Greatest. The greatest single digit or one digit number is 9, and the smallest one digit number is 0. Okay, clear? But in 2 digits, these are the numbers. Because see, why call 2 digits? Because the moment you write 10, you write 1 and 0. Means what? You're writing 2 digits. You're writing 2 digits. You're writing 1, this one, and then you're writing 0. So after 9 comes 10. If you see 9, then 10. The see, up to 9 is single digit, but say the moment you write 10, you're writing 2 digits. Then 11 is also 2 digits. 12 is also 2 digits. 13 also 2 digits, and in this way 14, 15, 16, 20, 30, 40, and in this way if you reach 90 is also 91, 92, 97, still 2 digit. 98 also 2 digit, and 99 also 2 digit. Because after 99 comes 100. See, when you write 100, you write 3 digits. 1, 2, 3. So means these are 2 digits. So these are all 2 digit numbers. But if you look at these 2 digit numbers, the smallest 2 digit is 10, and the largest or the greatest 2 digit number is 99. Okay, that means 2 nines, 99. So understood the idea? These are all the 2 digit numbers. 2 digit numbers start from 10 and end in 99. The smallest is 10 and the largest is 99. For 3 digits, after 99 comes 100. The moment I write 100 is 3 digit. There's no other number less than 100 which is 3 digit. The 100 is the smallest 3 digit number. But then after 100 comes 101, 102, 103, 200, 201, 202, 301, 300, like this. Till when? Till keep on writing. You'll find that 998 also you'll reach, 999 also you'll reach. Up to here it's still 3 digit. Okay, but after 999 comes 1000. But when I write 1000, see, count number of digits. In 1000 there are 4 digits. That means if you talk about 3 digits, the smallest 3 digit number is 100, and the largest 3 digit number is 999. 999. Just note 999 and 999. Single digit, double digit, 3 digits. Okay, and same way for 4 digits. The smallest 4 digit number is 1000 because after 999 comes 4000 and 4001, 4002. Still here say 4 digits, 4 digits, 4 digits. 9997 4 digits, 9998 4 digits, 9999 still 4 digits, still 4. That means the smallest 4 digit number is 1000 and the largest 4 digit number is 9999. Okay, same way the smallest 5 digit number I have not done here, so let me show you. After 9999 comes 10,000 and the moment I write 10,000, writing 5 digits 1 2 3 or 5. So 10,000 is the smallest 5 digit number, then 10,001, 10,002, and in this way the last the biggest 5 digit number is what? 99,999. So still 5 1 2 3 99,995. Okay, 5 digit. But after this, when you increase one more number, it becomes 99,000, so it becomes 1 lakh. You need 10 100,000. 1 2 3 4. Sorry, I've written one extra zero. So 1 2 3 4 5 6. Look, so 1 and 5 zeros. Means there's a after 99,999 comes 1 lakh, and 1 lakh means 1 and 5 zeros. This 1 lakh is the smallest 6 because the 6 is 1 2 3 4 5 6. Then 1 lakh 1, 1 lakh 2 in this way, 2 lakh 3 lakh 4 lakh, and the biggest is what? 9 lakh 99,999. So these are the biggest 6 digit number, largest 6 digit number. Okay, and so on. So in this particular question, we are to do for this number. Okay, see the question. Find the greatest number of 6 digits. Actually, from 6 digits, the smallest 6 digit number is this one. 1 and 5 zeros 1 lakh, and the largest 6 digit number is what? Just give 6 nines, because after this will become 10 lakh. So 9 lakh 99,999 is the largest or greatest 6 digit number. So the question is what? Find the greatest number of 6 digits. So we have to do something with this. Okay, find the greatest number of 6. So is this the answer? Then the question goes further, because see, the answer depends on the complete question. Find the greatest number of 6 digits. Okay, so far this is the greatest number of 6 digits, 9,99,999, which is exactly divisible by 24, 15 and 36. This number should be completely divisible by 24, 15 and 36. Let's check. Let's check whether we can divide 9,99,999 by 24 by 1 2 3 4 6 by 15, and whether we can divide this 9,99,999 by 36. So if the remainder comes 0, then we can divide. If the remainder don't come 0, means we cannot divide. Okay, so let's see. Okay, I'll do the divide and I'll show you the answer directly. So students, I have done this divide. When this greatest number of 6 is, that is 9,99,999 is divided by, so when this greatest number of 6 is it, this 9,99,999 is divided by these three numbers, 24, 15 and 36, because the question is saying find the greatest number of 6 is it, which is exactly divisible. That's what, yes, so far we know that 9,99,999 is the greatest number of 6 digits, but the question is what, is this the required answer here or what, or no, or there's some other number? Because see, we have got the greatest number of 6 digits, but is this divisible by 24, 15, 36? Because if this is exactly divisible by 24, 15, 36, means we've got the answer. But that's what to check. I've divided here 9,99,999 I've divided by 24. This greatest number of 6 digits I've divided by 15 also, and then this greatest number of 6 digits I've divided by 36 also. And see, after dividing all this, here remainder I got 15, means 24 cannot divide exactly this greatest number of 6 digits. Here also remainder I got 9, that means remainder of 0, that means what, 15 cannot divide this greatest number of 6 digits completely. And when I divide this greatest number of 6 digits by 36 also, this 36, here I got remainder 27, that means what, this 36 also cannot divide this greatest number of 6 digits completely. That means what, so we can agree that yes, there is no doubt that this is the greatest number of 6 digits. More than this we don't have, but this is not the required answer, because this greatest number of 6 digits is not completely or exactly divisible by 24, 15 and 36. As you see, remainders are not 0. Remainders are 15, 9 and 27. Okay. So the question is about how to get the answer, because we need greatest number of 6z, but at the same time that number should be divisible completely by these three given numbers. Okay. So understand the point? So now to get the answer, what to do is that, see the procedure or working plan here. The working plan or the procedure here is, what is that, yes, we'll write this greatest number 6z, which is 9,99,999, because this is going to help us. Okay, that's very important. But after writing this greatest number 6z, then we'll find the LCM of these three numbers, given numbers. LCM, keep in mind, we'll find what? Lowest common multiple. Okay, and by that lowest common multiple, we'll divide this greatest number 6z, because see, that that LCM will contain all these numbers, or you can say that LCM is divisible by all these three numbers. So by the LCM of these three numbers, we'll divide this, and whatever remainder comes, that remainder will subtract from here to get the answer. Okay, and that difference, from this number we subtract the LCM of this three, and the answer that you get, the difference that you get, that number is the required number, which is greatest number of 6's also, and plus which is divisible by all this number, because LCM is what? That number is divisible by 24 also, 15 also, 36. That's why we divide by LCM. Okay, so let's start then. So first of all, we'll write the greatest number of 6's. Okay, so here's the solution. Okay, the greatest number of 6 digits, there should be 6 digits, is what? Is 6 number of 9's. So this is the greatest number of 6's. 1, 2, 3, 4, 5, 6. 9,99,999. Okay, so this is the greatest number of 6's. Okay, so now we'll find finding the LCM of the three given numbers. And which are the three numbers given to you? Three numbers given to you are what? 24, 15 and 36. So let us find now the LCM of 24, 15 and 36. So 4 is even number, so we can divide by 2. 2 ones are 2, 2 is 4. 12 is even number, 2 6 is 12. 6 even number, 2 3 is a 6, and 3 is a prime number, so 3 ones are 3. 15 you can divide with 3 because the odd number can divide with 2, so by that equal 3. 3 5 is 15. 5 is a prime number, 5 ones are 5. 6 even numbers, so we can divide by 2. 2 ones are 2. 3 minus 2 1, 1 and 6 16. 2 8 is a 16. Even number again because of this 8. So 2 9s are 18. We can divide by 2. Now 9. 9 is odd number, can divide by 2. So we should divide 3. 3 3 is a 9, and 3 is a prime number. 3 ones are 3. So now we'll write prime factorization. Okay, so prime factorization of 24. So I got 2 into 2 into 2 into 3, which you write in power notation. 2 3 times, so 2 cube, and 3 only 1 times, 3 power. So now we'll write prime factorization of 15, which you got 3 into 5. 3 also 1 time, 5 also 1 time, so directly. Now I'll write prime factorization of 36. So 36 we got 2 into 2 into 3 into 3. So 2 is a prime factor, and 2 times coming power 2. 3 is a prime factor, 3 coming 2 times power 2. Okay, so we have got all the prime factors. So now we'll find LCM. Okay, because this LCM is going to help us. Therefore LCM of the three given numbers, 24, 15 and 36. So let's find LCM. LCM means product of all the prime factors with their highest power. So which are the prime factors here? You can see that the prime factors are 2, 3 and 5. So in all this prime factor we have only 2, 3 and 5 only. So we'll write 2 into 3 into 5. There's no other prime number. But now we'll write the highest power. 2 power 3, there's no 2, and 2 power square, power 2. So highest is 3, 2 cube. 3 power 1 and 3 square. In two numbers we have 3 prime factor, but highest power is 2, so we'll write here 5 is present only in 1, so power is also 1, highest power 1, so write 2 cube, 2 into 2 4, 4 into 2 8, 3 square 3 into 3 9, and 5 power 1 is 5. So now we'll apply 8 5 40, 40 into 9 and 4 36, 360. Okay, 8 5 40. So the LCM is coming how much? 360. That means this 360 is now completely divisible by 24 also, 15 also, and 36 also. Okay, because it's LCM. Now we'll divide. See, dividing this greatest number of. So now we'll divide the greatest number of sixes. That is 9,99,999. So now dividing 9,99,999 by 360, we get. So let's divide. See, 9,99,999. This greatest number of sixes. Now we'll divide by 360. Okay. So let's divide then. 361 is 360, 362 is 720, and 368 is 1080. 6 times will become, because I take 3 digits, so 1000 will break because it's 99 and 1000. So 999 and 1000, obviously 1000 bigger. So we'll take only 2 times. 362 is 720. We subtract 9 minus 0 9, 9 minus 2 7, and 9 minus 7 2. Now this 9 is done. Now we'll divide by 360 into how many times? Let's try by 7. 70, 76 42, 721, 25. Yeah, because if I take more, then it'll come 2800 something. So it'll come bigger. So it means I should do 7 times. 8 times is going to be bigger. So 7 times will be 2520. 2520. So subtract 9 minus 0 9, 9 minus 2 7, and 7 minus 5 2. Now whose turn? This 9's turn. This 9. So again, see, almost same. So that's why again 7 times 2520, like before, like previous. So 9 minus 9, 9 minus 2 7, 7 minus 5 2. The last 9 now. So 360. 7s are again same, 2 5 2, so because 8 times will be big. So the remainder is coming 9 7 and 2. Now we have nothing to come down, so there's the remainder. Okay, so we got the remainder how much? 207. Okay, so it means that when you divide this largest number of six digits, largest number of sixes by the LCM of these 3 given numbers, 360, you'll find that remainder is 279. That means what? The largest number of 6 digits is not divisible by the LCM of these 3 given numbers, 360, because remainder is coming 279. It means that from this largest number of 6 digits, if I subtract this remainder 279 from here, then the difference, then the result, then the answer, the difference of these two, the largest number of 6 digits and then the remainder, the difference of these two, this and this difference of these two, will be exactly divisible by the LCM, because if I remove already from here, from this main number, this 279, then remainder will not remain anymore. Okay, clear? So that means that new number, after subtracting this remainder from here, that will be exactly divisible by 360. And if it's exactly divisible by 360, means it's also divisible by 24, 15, 36, because after all 360 is the LCM of this one. And moreover, that will remain still 6 digits only. Okay, so now we'll write here, therefore, see, this is a question, find the greatest number of 6 digits exactly divisible by this one. So see, we'll just copy this one. Okay, therefore the greatest number of 6 digits, therefore the required greatest number of 6 digits, which is exactly, the greatest number of 6 digits which is exactly divisible by divisible by what? By, which is exactly divisible by, which is exactly divisible by 24, 15 and 36 will be equal to what, from this greatest number of 6 digits, that is 9,99,999, we subtract the remainder. So this remainder is equal to what? 279. Okay, because here remainder is what? 279. This remainder. So we subtract from here. And see, when you subtract 9 minus 9 0, 9 minus 7 2, 9 minus 2 7, and the 3 nines will come same. That means it's 9,99,720. And if you look very carefully, count the number of digits. It is still 6 digits. See, 1, 2, 3, 4, 5, 6. That means 9,99,720. So this is the required number, which is the greatest number of 6 digits, and also which is exactly divisible by 24, 15 and 36. Okay, clear? That means if you divide this number by this three numbers 24, 15, 36, you will get remainder 0. And moreover, it is still 3-digit number, 6-digit number. Okay, still 6 number, and this is the greatest. More than this we don't have. Okay, which is 6-digit, and this divisible by all three is not possible. Okay, so this is the required answer. So this is the greatest number of 6-digit, which is exactly divisible by this 24, 15 and 36. Okay, so I hope you have understood the working plan or the procedure. You have understood the trick. So what we have done, we write the 6-digit number, highest greatest number of 6 is here, 6 nines. Okay, so in single digit is 9 only, in 2 digits is 99, 3 digits is 999. So for 6 digits is 9,99,999. Okay, then to find the answer, we have already tested that this number is not divisible completely by this one, though even though it's 6 is number but not divisible. Okay, so to find the exact number, only getting 6 number, highest number is not enough. We have to get the exact number which is divisible by this number. So to find this, what I'll do, we have found the LCM of 24, 15, 36 by prime factorization method. Okay, LCM coming 360. Now by this 360 we divide this greatest number of 6 digit. So when I divide, I find that it's not completely divisible, but remainder is coming 279. So we use the idea that since this greatest number of 6 is not divisible by 360, which is LCM of these three numbers, and remainder is 279, so we thought that why not remove this 279 from this biggest number, because the difference after that, this number will be exactly divisible by 360. Okay, so means finally we have got the answer. So what we have done, after dividing, after finding the remainder, then we found the required answer. If the greatest number of 6 digit exactly divisible by 24, 15, 36 is this one. From this we will subtract 279, the remainder, and then this is the answer. And this, if you divide in the rough, you can try, or you can do in the rough in your rough copy, and you try to divide, you'll find that if you divide this number by 24, 15, 36, you'll get remainder exactly 0. Okay, so you can check this by yourself. So hence we found the answer. Okay, so I hope you have understood. Thank you.